Welcome to this 7th video in the yt-napari tutorial series. In this I'm going to continue the discussion of loading in time series into yt-napari, but we'll bring in Dask to help deal with some memory issues and speed up some of the processing. So last time we covered loading time series from the Napari GUI with yt-napari, and then we also introduced the yt-napari time series module, talked about how to use that to load in slices. And then in this video, we will load in some regions as well, but we'll use Dask to get around our memory issues. And same as last video, you'll want to make sure you have the full yt cosmology data set from the ytproject.org/data sample data repository. And thanks to CZI. Okay, so we've got our yt-napari tutorials environment set up. In this video, you'll also want to make sure you've got Dask, so do a pip install Dask, and I'd recommend just doing the complete install. Gets you a few extra nice things like the dashboard and other things, and it doesn't take up that much extra time to do the complete. So I already had it, so that went pretty quick. Let's start our Jupyter Lab notebook. Okay, so let's get started by importing what we need. We need Napari, we need yt, import time series, from yt-napari import time series. And then from dask.distributed import client, and we will set the yt log level to error only using the value of 50 there. Great, so let's first off, let's grab our Napari viewer as usual. And great, let's just dive right in. So let's say we want to create our time series region. So remember that this region object will get applied to each time step in our time series. So this is going to be the field we want to sample. And then you can provide a left edge, right edge resolution, but we'll just cover the whole domain and use the default resolution, which is 400 by 400 by 400 pixels. And then if we just went and did a time series, add to viewer slice for our enzo tiny cosmology file pattern, we can do enzo tiny cosmology /dt for wildcards, and again. And so that up a little. If we set use Dask to true, this return delayed function or parameter is by default true, but I'll add it just to be explicit here. And load as stack is equal to true. So if we just went and did this, what it would do is it would initialize a Dask client for you with the default settings, and then it'll return a delayed array where with just one or two time steps loaded into memory, and which allows you to load in the full time series into the Napari viewer without loading the full array at once. So if you could just go and do that, but I'm actually gonna come back up here and start up my own client. We'll do 5 workers and threads per worker equals 5. And let's take a quick look at the Dask dashboard here. So we see our 5 workers here. Nothing going on quite yet. One of the interesting things about this is that using standard YT, you can't really use Dask out of the box with it. Some experimenting, kind of working in some Dask functionality into YT. But at present, you can't actually use Dask for processing single data sets. But in this case, what we're doing is we're cycling through each of the map time steps and loading those separately as YT datasets. And so what Dask does on the back end here is it hands off the processing of each of those individual time steps to a different thread or worker. And so that actually scales nicely with Dask. You actually can also handle the multiple threads. So like generally YT is not necessarily thread safe, but so far in my experimenting, this actually works pretty well and works across threads. So with that said, let's give this a go. Oh, actually before that, one more thing is it's important to set some contrast limits here. So this will be the contrast limits for our color map that's displayed. If you don't set this, though, it will have to go and actually sample all of the time steps to figure out what those contrast limits are. So definitely recommend setting that here. So let's go -30 to -27. So this will be in log 10 units of density in the code length density. And then let's also give it a good color map. And hit enter. Yeah, so that was pretty quick because it axis is one of the first time steps, and then the middle time step in order to have something to initially load in. So what we get initially, we are in our 2D field, and so the top slider here is a slider through space. And as you click through, it'll go and load in that slice. And then the bottom slider here is through time. This gets a little bit more interesting with the 3D view, I think. Because when you switch to 3D, it'll load in the full 3D field for our single time step. And then now when you click through the time axis, Dask on the back end will go and load in that particular time step that you want. So you have a couple of seconds to lag between switching around time steps, but it's still pretty cool to be able to actually, click through your time series interactively here. Did not pick a good value for the contrast limits for all of the time steps, but yeah, so that's pretty cool, I think. Let's now delete that though and go back and talk a little bit about slices. So similar, you can do all this with the slice. Yes, density, normal axis. Let's cover the full domain up to normal resolution. That's all we need. So with a slice, since we know, so first I just replaced the region with the slice variable there. So with the slice, we know we can fit everything in memory. So we could, if we actually, let me make sure we're back into 2D. So if we just run this as is, it'll load the slices lazily, which would allow you to step through without loading the full slice in memory. But since it's okay to actually fit everything in memory, you can set this return delayed as false, and instead what will happen is Dask will immediately distribute all of the time steps to different processes and extract the values for the slices at those time steps, and then return a single in-memory array. So if we do this and go check out our Dask workers, we should see stuff happening. There we go. So all of these processes are going to sample different time steps and returning the fixed res samples out of there. And that was pretty quick. So that was much quicker than, just waiting for yt to serially process all the time steps. And now when you, this axis here is time again. And if you switch to 3D, you get your space plus time 3D view here. So that about covers everything that I wanted to touch on for basic loading of time series. The next couple videos would actually talk about what to do with data once you have it in Napari. I'll walk you through some of the options for image segmentation and what you can do with that sort of processing. And I'll actually bring in some plugins other than yt-napari, because some of the exciting stuff in Napari is the ability to use all of these methods that have been developed by the bioimaging community on some of the data sets that yt can handle. So I'm excited to get to those videos. And thanks for watching so far. See you next time.